Hi, today we'll be doing 18H. It talks about families of functions, it talks about differentiation, it talks about stationary points, and it talks about translation of points and so on. Okay, a combination of a lot of concepts learned. So let's look at the first example, example 23. I'm going through the examples because I found they're pretty good and they covered a lot of concepts that it would be good to touch upon. So consider the family of functions with rules of the form f of x is equal to x minus a whole squared times x minus b, where b is greater than a. So b greater than a being given obviously will come into play later on, maybe somewhere along the way. Now find the derivative with respect to x. So in order to find the derivative here, this is a whole topic based on the CAS here, exercise based on the CAS. So you put your equation in. Okay, now if you want to know how that came about, preferably put it from your XAB from this window, okay, which is your ABC window. And so once I put it in, and then I went to, as you can see from here, sorry, it moved up. You go to action, transformation, calculation, differentiation, and then you type this in, okay, and that's what you get. But obviously this is the expanded form and this is the factorized version, so because it didn't look anything like that, so then I thought, okay, fine, let's factorize it then. So action, transformation, factor, put this guy in here, and I did find that it looked like that answer. So that's the way you factorize it, okay, and you get that in the form f dash of x. And then after that, find the coordinates of the stationary points on the graph y is equal to f of x. Now we know that stationary points implies, sorry, let me just clear this in case I want to use it again. Stationary point implies f dash of x is equal to 0. And that's exactly what I did, because I had f dash of x over here, I equated it to 0, and then I got x is equal to a. And then when I solved for x over here, I moved transposed terms and I got x is equal to a plus 2b divided by 3. But it's a stationary point on f of x. Therefore, a point means an x and a y. I have two values of x over here, so I take it and put it back on the f of x equation, which is this. And so when I put a into this equation, I get a minus a whole squared, which is 0 times x minus b, which is 0. So the point is a 0. And when I took x is equal to a plus 2b divided by 3 and I put it in the place of x here and here, like I've shown you here, I solved that by taking the least common denominator, and I got, okay, 3 here, so I got a minus 3a, and that's a minus 3b, and I simplified it, and I got this. And then here, actually, it was a square, okay, which I forgot to put. So please put a square here and a square here. But I did look at it and I put a square there. And so if you take out a minus 2 common, you're left with an a minus b, and that's okay in brackets. And so because it's a square over here, I put a square. And then why did I do that? Because I saw that there was an a minus b that could be actually pulled out from both these, okay? And so that gives me minus 2 whole squared, which is 4. Actually, it should be plus 4, sorry. It should be plus 4 over here. Sorry for all that, those mistakes over there. Anyway, I did it in a rush, so I can clearly see that this should have been a plus over here. So plus 4a minus b whole cube divided by 27, okay? So please be careful over here. Keep putting the square, otherwise the answer doesn't make sense. And be careful to see that this is a plus over here, okay? And now let's look at part C. If x is less than a, if x is less than a, okay? So let's now move on to the next page. Okay. Sorry, show that the stationary point A0 is always a local maximum. Now, in order to be a local maximum, obviously A0 should basically be this point here. So which means it should have been a positive gradient here and a negative gradient here. So now we have two stationary points, this one and that one. And they're saying show that this one, okay, is a local maximum. Now we know f dash of x is equal to x minus a, 3x minus a minus 2b. Now we have to consider values less than a and greater than a, okay? Simply because we have to prove that all values of x less than a have a positive gradient, and this side has a greater than a has a negative gradient. So what I did was I actually assumed values, okay? So if x is less than a, so I assumed a to be 3. And I said, so obviously if x is less than a, let x is equal to 2. And we know from the first part of this question is b is always greater than a. So if a is 3, I took b to be 5. And all I did was take the f dash. You know that basically when you find the gradient, you have to take the f dash x equation. And I subbed it in. Okay, we know f dash of x is equal to this. And so I subbed in the values of x, a, and b, and I got a positive answer. And therefore, I knew for all values of x less than a, it was a positive gradient. Okay, the slope was positive. Now, then I looked at x greater than a. So what I did was I took all these values. Now a is 3. I took a value of x which was greater than a, let's say 4, and anyway I kept b as 5. And I found that when I found the gradient sign, it was negative, and therefore it gave me a negative slope, and therefore it was this shape. So if I see here, this was a stationary point, less than a was a positive gradient, greater than a was a negative gradient, and that proves that a0 is a local maximum. All right, now let's look at the next question. Find the values of a and b if the stationary points occur where x is equal to 3 and x is equal to 4. So here they say okay, let me find the values. Okay, now find values of a and b if the station occur when x is equal to 3. Now if a is equal to 3, here a is less than b. Okay, as you can clear, a is less than b given. So let's now move down. So if you have to find the values of stationary points, obviously you have to put it into the f dash of x equation, and therefore we find x is equal to a. This is the same thing as what we did before, and so these are the two values x is equal of x's that we kind of found before. And they say if the stationary value is at x is equal to 3, so obviously that means if x is equal to a here, x is equal to 3 implies a is equal to 3. And then you again say x is equal to this, but x is given as 4, and therefore a plus 2b is equal to 12, and then solve for b, and that will work out to be b is equal to 9 divided by 2. Okay, so now let's move on to the next question. I think that was just the most difficult one. And so if you look at example 24, so it says over here the graph of the function y is equal to x cubed minus 3x squared is translated a units in the positive direction of the x-axis, which means x plus a, and b units in the positive direction of the y-axis. So whatever point you have for y, y plus b. A and b are positive constants, numerical values. Okay, find the coordinates of the turning point. Now the minute you think of turning point, that means f dash of x is equal to 0. So find f dash of x, and that's relatively easy. Equate it to 0 and you get the point x is equal to 0 and x is equal to 2. Now, because the coordinate means x and y of a turning point, when x is equal to 0, y is equal to 0. And when x is equal to 2, 2 cubed minus 3 times 2 squared will give you a value of minus 4 here. So the points are 0, 0 and 2, minus 4. The next question is, find the coordinates of the turning points of its image. Now, image obviously happens after transformation. Okay, and so here they've shown you two translations, in the positive direction of the x-axis and the positive direction of the y-axis. So take each of these 2 points and translate them basically. So positive direction of the x-axis, so 0 a units, so 0 plus a, and that's 0 plus b, and this is 2 plus a minus 4 plus b. And yep, those are the points. So hopefully you find it easy. Have a look at the work solutions as always and ask me if you have any problems with any of the questions.